All right, we gave them 3 more minutes. Thanks everyone for joining. I hope you can hear and see us all right. And yeah, welcome to the third part of Getting Started with Kubermatic Kubernetes Platform. As some of you might know, we open sourced Kubermatic Kubernetes Platform like 2 months ago, roughly 2 months ago in a community edition. And we already had part 1 and part 2 of Getting Started with Kubermatic Kubernetes Platform. And this is the third part where you will really will learn how you install it. In case you missed the first 2 parts, they can be found on our YouTube channel. Just look for Kubermatic on YouTube, and then you find the 2 other parts. In case you need to drop out early, we will of course also record this one and then have it on YouTube so that you can see it later on, or if you did not understand something at the first time, or yeah. So everything will be recorded. In case you have questions, we will have like a short question and answer session after the presentation. And also if you have questions in between, just post them in the chat, and then we will answer them either straight away or later. And with this, I want to hand over to our tonight's speaker, Youssef and Iacopo, who will now go into detail about Kubermatic Kubernetes Platform and how to install it.
Thanks, Chrissy, for the introduction. As Chrissy said, well, I'm Youssef. I'm a software engineer working with Kubermatic. With me tonight, there is Iacopo. He's a senior software engineer working, well, with Kubermatic also. We are working on the same team. Let's call it the backend team, where we work with everything related to Kubermatic backends and, well, distributed systems. So thank you for joining. And basically for this talk and for this, well, meetup, we will go through the Kubermatic installation from scratch. So there will be a theoretical part that I will present, and then Iacopo will do an installation from scratch of Kubermatic on, well, we choose AWS, it could be on anything else, with, well, a working Kubermatic from the deployment of the masters to the user clusters, and so on and so forth. We are assuming for this meetup that you have a Kubernetes cluster, a working Kubernetes cluster. If you don't have one, no worries. As Chrissy said, there will be a recording, so you can follow up later, and you can use, for example, Kube1 that well, it's an open source tool from Kubermatic that allows you to deploy very simply and easily Kubernetes cluster, and then so try out Kubermatic. And we will also be focusing on the CE edition, so the community edition. So we will focus on 1 seed. And with that said, let me begin with the Kubermatic architecture. So the main idea behind Kubermatic is basically we allow the users to manage a couple of Kubernetes clusters very simply. So everything is automated, and we also allow them to deploy lots of Kubernetes cluster wherever they want. So when I say wherever they want, say you want to deploy a user cluster on AWS or Google Cloud or another cloud provider, this is possible. So regarding this architecture, let's say we have 2 main components, what here in the diagram is called the operator infrastructure, and what is here called the customer infrastructure. So basically for the master seed cluster here, they are provisioned on top of a Kubernetes cluster. So in this scenario, in this architecture, this is the most basic and common one. The master and seed are running inside the same Kubernetes cluster. And basically on the, let's call it the master side, you have all the logging and monitoring stack, but you also have, and more importantly, the Kubermatic namespace, where you have everything related purely to the main Kubermatic installation. So the master, the dashboard, API, the controller manager. And then you have what is called here the customer cluster, which is basically the control plane of each Kubernetes cluster that you deploy. So again, what we are doing is we are deploying Kubernetes cluster, and we are decoupling them by taking away the control plane from the end user and handling it and managing it from our seed side. So all those customer clusters that represent the seed. So we are managing the control planes, and the worker nodes of your Kubernetes clusters, they will be running wherever you want them to run. So say you have a Kubernetes cluster that will be running on AWS, this one on Microsoft Azure, this one on Hetzner or another cloud provider. And I would say with this, we have the main architecture and the simplest one. Now, say you have...
Youssef, one question. We have one question in the chat. What is an operator and a customer here?
Oh, sorry, let me go back. Can I... give me a sec, because... okay, can't go back. Just a sec. Up. Yes, sorry. The question was, what is the operator here?
The operator and a customer, like, or maybe I can also.
Yeah, okay, because I don't have the questions open, so maybe that could help.
I think that the question is what operator infrastructure and customer infrastructure refers to. I think that this picture depicts something like a Kubernetes provider, service provider, like someone that provides a Kubernetes as a service product. So the operator is the provider of the managed Kubernetes cluster, and the customer infrastructure is what is actually visible to an end user, to the consumers of the user cluster. I don't know if I replied to the question, but I think I did.
Yeah, thanks. That answers the question, I think.
Okay, perfect. So in this case, let me continue with another architecture. It's well, let's call it the large scale deployment, where you have, well, as Iacopo said, let's use the case of a service provider. So you have lots of customers, you have lots of Kubernetes clusters, and they're basically running all across the globe. And what you want is to have like a couple of seeds that are near the location of those worker nodes. So in this example, we have one in Europe, one in the US, and one in Asia. And same for the customer clusters. So the worker nodes of the Kubernetes cluster that are running near those seed clusters. And this is basically done to, well, typically reduce the latency of when I'm speaking about latency, I'm not speaking about your application that are running inside the worker nodes, inside the user clusters. I'm speaking about the control traffic that is running between the user cluster and the control plane. And speaking about this control traffic, I didn't speak about it, but yeah, obviously, since it's a control plane of a Kubernetes cluster that you are running inside the seed cluster, so you have all the components of the classical components of Kubernetes, like an etcd, API server, scheduler, etc. But you also have like dedicated components from Kubermatic, I would say, the machine controller and the OpenVPN server and client. And I will talk about those two components in the next slide. So we have what we call an expose strategy. Basically, this one is important because since we are decoupling the Kubernetes clusters, there are communications that goes on between the user clusters, and typically the pods and the kubelet, they need to speak with the API server. So you need to make the API server available to the outside in a secure manner, so that when you have a user cluster, so basically the worker nodes, typically maybe they could be running on Microsoft Azure, and you have your seed running on AWS. So obviously you want some security, and you want the possibility simply from the networking point of view to be able to reach those API server. So that's why we have deployed this OpenVPN part on each control plane and Kubernetes cluster. You have an OpenVPN server and OpenVPN client. So what those components do, they basically secure the traffic. This is the first step. So you have a completely secure traffic between the API server and the components on the worker nodes. But also they allow the routing to work properly, especially in the case of having private networks. So you don't want to open access to one of your worker nodes from the outside. So in this case, the OpenVPN client can initiate the connection to the server and basically allow the traffic to go back and forth between, well, all the components of your user clusters and the control planes. In Kubermatic, we have 3 expose strategy, basically to allow this whole thing of exposing the API server. And basically, as I said, there is an OpenVPN server also for control planes, which is basically exposed. So we're exposing 2 ports to the outside, depending on where you are located. Of course, when I say outside. So you have one node port. The node port one is, to put it simply, like the Kubernetes node port service. So we are exposing or opening ports on the nodes themselves. So the control plane nodes. You have the load balancer. This is the one by default, and this is the one that probably Iacopo will use for the demo. It's basically provisioning one load balancer, service type load balancer. So you will have a public IP, and you will have 2 pools that are randomly selected and generated from the random pool of the something going on from 30,000 to 32,000 something. And basically it will take care of the whole load balancing to the right control plane. And finally, we have one load balancer per user cluster. And this one basically, well, as a global load balancer, it exposes one load balancer per control plane. This solution is good if you have, well, 1 or 2 or maybe 3 Kubernetes cluster. But if you have a lot of those, well, the cost will directly go up because you have a static cost for each load balancer, usually on public cloud. So yeah, this one is probably limited for testing purposes or small clusters. Me and Iacopo, we're working on a new expose strategy that will be using basically one load balancer with 2, well, defined ports, HTTPS and proxy port, that will basically probably replace this global load balancer one and allow just the exposure of 2 ports. And yeah, there would be no limit of ports like the global load balancer because we're using random ports. So that's it for the expose strategy. Regarding this webinar, so regarding the master installation, basically we'll be using 2 resources. Let me open them. So the first one is a GitHub, which is GitHub Kubermatic Labs KHC install webinar. Maybe someone can put it in the chat, those 2 links, the first one and the second one. Let me, sorry, just go back to this one. So yeah, this link, this GitHub repo, it's a public repo, so you can access it. And basically what it contains, Iacopo did a script in this one to facilitate and make it easier to install Kubermatic. Basically, you just need to clone it and have this generated SH file, which is shell script, and run it with some specific flags. And Iacopo will go through all those flags and installation. So don't worry about this. So this is, well, it is needed, and there is a documentation. Basically, we are following this documentation, the official one. So install Kubermatic CE to install the whole Kubermatic. So install Kubermatic CE, add seed cluster for CE. And again, Iacopo will go through all of those, but yeah, we'll just be using those 2. Nothing fancy, to be honest. And with that said, so yeah, we use a script. We have the values file and the YAML files that are needed to install Kubermatic, as Iacopo will show later. And once those value files are generated, we can proceed with the installation. And first thing first, we'll deploy a storage class. So depending on your cloud provider or wherever you are running your Kubernetes cluster, you need to basically customize the storage class. But we have quick start examples on the documentation that I just showed you. And we also need to set up Tiller for the Helm charts. We're still using Helm version 2. We will be introducing a new Helm version 3 installer in the near future. But for the moment and for this meetup, it will be Helm version 2. And basically to make the master work, and the whole Kubermatic work, we just need four files and 4 charts. I would say the Nginx ingress controller. Well, this one, as the name implies, it's an ingress controller. It will be needed basically to forward the traffic, route traffic properly to the Kubernetes cluster. We have a cert manager. Well, it's used to generate the certificates, production certificates with, let's say, encrypt, and can give you all this certificate management. The OAuth chart, which is responsible, it's using DEX, and it's responsible for all the authentication. So basically how to access the Kubermatic dashboard, for example. You can, well, do lots of configuration and use SSO, SAML, and all the kind of basically authentication method. And finally, the Kubermatic CRDs and the Kubermatic operator chart. And basically those one will be responsible for deploying all the Kubermatic components to your Kubernetes cluster. So once you have installed those charts, you just need to configure the DNS. Basically, you will be accessing the Kubermatic with a dashboard. Now, it is installed, but you still need to access it. There is a load balancer, service type load balancer that is created, but obviously since you don't have any DNS records, you can't access it. So in our case, for this example and for the slide, we are using Route 53 from AWS. You can use anything else, it doesn't matter, it's just DNS. So how to get the external IP? You just do a kubectl get services on the Nginx ingress controller, and you get this external IP. It could be an FQDN, whatever the cloud provider you're using or the provider you're using. And once you have this, you can just create your DNS record in your basically DNS provider, and then you can access the dashboard. Just a point for this meetup, we have put for the authentication of the dashboard a very simple address, email address, and a very simple password called password. Obviously, this is for lab purposes. So if you plan to make it for production, please change those values and have something definitely more secure. So with this, we conclude the master installation. With the seed installation, basically it's even simpler. So to put it simply, the seed file, the YAML file, is where you defined where you want your Kubernetes worker nodes to run. Okay, so if you want them to run in AWS in the Frankfurt zone, you add the data center, and you add the Frankfurt zone, data center AWS, Frankfurt zone, and that's it. And once this is done, and obviously you have an example with documentation, and again, Iacopo will show you all those in details just in a couple of minutes. You can apply the seed file, and the Kubermatic operator that we have deployed previously will take care and install all the required components. And again, as with the master, and as I said a little bit earlier, we have to expose the API server and the OpenVPN server. So basically, what the Kubermatic operator will do is it will also deploy the node proxy, which is basically Envoy in the background, and it will create the right basically service. And what you need to do from your side, again, update the DNS records on your DNS provider to target this specific load balancer. A point on this DNS record, in the case of the CE edition, it will need to be a wildcard because you can have multiple Kubernetes clusters, so you don't know the name, let's put it this way. And it will need to have the seed name .kubermatic URL. So Kubermatic URL, obviously this is your URL, so say test.com or test whatever, or whatever you want. And the seed name here will be Kubermatic, because by default with the Kubermatic CE edition, we just have one seed and it's called Kubermatic. With that said, once it is applied, so you can have access to the dashboard, and even before, after the master installation, you have access to the dashboard, but there is no point in showing the dashboard if you can't deploy your user cluster because you don't have a seed. So that's why I'm showing this right now. You can just click on add project, put the name, then you can basically create the project. You put the name of your cluster, the Kubernetes version, the provider, and the data center. In my case, I put AWS with the Frankfurt availability zone. You could put, again, anything else. I mean, if you have an AWS account, it's simple, as I will show you the next slide. And basically, either you have a preset where you can directly define your access key ID and secret access key. Well, this is the case of AWS. Obviously, if you don't use AWS, you won't have those exact same fields, but you just have to populate those if you don't have a preset file, and it will automatically populate and take care of all the routing and VPC selection, route table, etc. Obviously, you can override those values. I mean, you can see the subnet has been selected automatically. I mean, I didn't type it. And you can choose a number of replicas. So to put it simply, the number of worker nodes for your Kubernetes cluster, disk size, OS, and yeah, some, if you want a public IP or you want a private network, whatever, you can, before creating the cluster, have a big overview of what you want to deploy. And once it is done, you create it, you wait 2 or 3 minutes just to have the worker nodes deployed. Here, I just have one replica, and it is in EU Central 1C, which is basically Frankfurt. It has been deployed, and this is basically, this part is a part of the control plane running on the seed side, so the master side, where, well, we have all the components health. And yeah, the last thing you need to do if you want to install your application, and for your users, if you have customers wanting to install and deploy their applications and whatever websites they want to on the worker nodes of the Kubernetes cluster, you just need to download the kubeconfig file here with this arrow, and that's it. Give it to the one who wants to deal with the Kubernetes worker node. And that's it from my side. So I will let Iacopo continue, share his screen, and do the demo.
Yes, thank you, Youssef. Let me share my screen. Up. And share. Okay. So here we will install a Kubermatic platform. So as Youssef already mentioned, the prerequisite is to have a Kubernetes cluster running. I have prepared one. And it's an empty one, a new one. And in our case, we are going to install it in AWS. So we also need, of course, access to the console for the DNS configuration. So we will try to follow as strictly as possible the Kubermatic install documentation. I shared the link. So let's start. So first thing, we have to download the latest Helm chart package that we create for each Kubernetes Kubermatic release. We can just copy and paste this to my terminal, and up it basically I downloaded the latest tarball. So the latest stable Kubermatic version is 2.14, and 2.14.5 is the latest released version. And here in the charts directory, we have the Helm charts we will use to install Kubermatic. So first of all, we need to create a storage class, because we need to create some persistent volumes for the etcd, basically for the control plane of each user cluster. What I forgot to say is that here we are going to do the simplest Kubernetes installation. As Youssef explained, we have those concepts of master and seed clusters. In this installation, they will be collocated in the same Kubernetes cluster. So let me apply this manifest. Okay, storage class has been created. Next, we need to install Tiller, that is the server part of Helm. As Youssef also mentioned, we are still relying on Helm 2, even if Helm 3 is there and it doesn't require any server part. We are working on updating our installation script, but for the moment, let's stick to Helm 2. So I also run those commands, and now I have Tiller installed in my cluster. Here, for the purpose of this demo, I'm not putting any security, but for a production environment, I suggest you to put in place some authentication between Helm and Tiller, for instance, with the mutual TLS. Now, let's see what are the inputs that are required for the installation. The main file we need is this values.yaml that basically contains all the values that are required for the Helm charts. I won't go in detail on all the options because there are a lot, but as Youssef also mentioned, we are going to use a small script that is going to adapt to create a value file according to the needs we have for the installation. This is also something that can be used for demonstration purposes, but of course, for a production environment, I highly suggest you to read the doc and understand all the values that can be set. So let's run this command that you can find in the GitHub repository. I also put the link in the chat. I'm just going to provide him the kubeconfig pointing to the cluster I'm using and the domain I will use for this Kubermatic installation. That is meetup.lab.kubermatic.io. Okay, and please, Youssef, tell me if you see any typo to avoid problems.
Yeah, it should be okay.
Okay, now the output of this script is these values.yaml, and there are other two files that we will see later. But let's go back to the installation documentation so we can start applying the Helm charts. So the first one is for applying the Nginx ingress controller. We need an ingress controller in order to expose the control plane of the Kubernetes cluster that are hosted on this seed cluster. So let's do it. Oh, so, okay. I used the Helm to apply the first chart. Let's go to the second. The second is Cert Manager. We are using a Cert Manager in order to generate the certificates that are required by the platform. For this demo, we are using Let's Encrypt staging as an issuer. I don't know if you are aware of Let's Encrypt, but basically allows you to create to generate certificates signed by well-known certification authority. As I'm using staging, I had to put the intermediate certificate manually in my browser, but if you use Let's Encrypt prod or if you use your own certificates, you don't have this problem. So, so let's do it. Okay. Let's wait for it to be applied. That's it. I'm just checking that everything is up and running. So let's wait for the webhook to be ready, and then we can continue, okay, with the rest of the installation. So first, next component, we need to install auth. This will install DAX. That is basically a component that is used for the federation of the users. Basically, it's used to log in to the Kubermatic UI with your users. In our case, we are using a static user, but you can connect it to your LDAP or to whatever identity provider, like Google, AWS, or the main one, let's say. Okay, so let's install it. And here we are. Okay, everything is running perfect. Okay, so here we have some comment to verify that everything has been deployed correctly, but we already verified it. And next, we have to do the first part of the DNS configuration. So we can run this command, and we can get the external IP associated to the service of type load balancer that have been created when we deployed the Nginx ingress controller. We can copy it, and at this point we have to go to the Route 53 console and create an A record that is pointing to this host. Find a simple record. We call it kubermatic.meetup.kubermatic.io. I already prepared the hosted zone. And we are using an alias to a load balancer. It's in Paris region. Up. And that's it. So the record now is created. We can quickly verify that the configuration, that the DNS configuration has been applied. We can do a dig, and we can verify that we get the same thing by resolving this. And yes, so the first part of the DNS configuration is done. Next, we have to install the Kubermatic operator. That is the one that is taking care of creating the controllers that are required by Kubermatic. So first, we need to create the CRDs that are needed by those controllers. For one that don't know, CRD stands for Custom Resource Definition, and it's a way of extending the Kubernetes API by defining your own resources. We have a bunch of them. And we do the same thing. We use the Helm client to apply the chart. Okay, so This is done. So we can check if the operator is up and running. It's still downloading the image, so let's wait a moment for it to come up. It should be quite quick. Okay. And let's go. So at this point, we have to provide the configuration for the master Kubermatic cluster that is provided by this Kubermatic configuration that is a CRD. So this file has been also generated by the script I ran before. So I have just to apply this kubermatic.yaml. Oops. And now this is the global master configuration. This should trigger the creation of the components that are needed for the Kubermatic API. There could be some transient errors. Yeah, but probably, well, doesn't seem to be transient. Let me see if I did some mistake. Let me check if I put the good configuration. Meetup.lab. Probably I didn't use yeah. I have to put kubermatic.meetup.lab. Yeah, this is a mistake. It's not. It shouldn't be too hard to fix it. Let me do it. Yeah, in fact, it was the correct one. So yeah, unfortunately, I have to reapply the charts, but let me do it quickly. So Nginx. Oh, yeah, this is the most important one. Okay, now I reapply the resource because now, sorry, kubermatic.yaml. Basically, it contains the value for the domain, and before I had the wrong one. So let's see if this addresses the problem. So we have one of the two that is running. Let's wait for the other to come up. Then the old one should be terminated. Sorry for the mistake, but it arrives. 20, okay. Should be good. And this terminating, okay. Now everything looks good. As you can see, everything is now up and running. So let's go to the next step. As you can see, I did that and we are in the same situation. So everything is up and running. And this basically concludes the first part, that is the setup of the master cluster. Now we go straight to the second part, that is adding a seed cluster. As I said, we are going to use the same Kubernetes cluster, so we will have seed and master cluster co-located. I'm going to skip the first part because it's not necessary for the Kubernetes platform to work. This is just to have backups of the etcd used by the user clusters. So this is very important in a production environment, but not here. And we go straight to the creation of this other resource, that is another custom resource called seed, that will trigger the creation of the components used for the seed cluster. As you see, we have some new components that are that have been deployed. We have the node port proxy that is related to the expose strategy, as Youssef already mentioned. We have the seed controller manager and the seed proxy. So now everything seems to be up and running. And then we have to pass to the second and final DNS configuration that is required basically to access the user cluster that we will create on this seed cluster. So we have up. We have again to list the services, this time in the Kubermatic namespace. And we have this service of type load balancer that is used by the node port proxy. So this time we have to create a wildcard DNS entry. Let me show you how to do it. In AWS, at least, of course, you can use other providers. Find simple record. So here there is a bit of repetition because the seed is called Kubermatic, and the domain I use for the platform also contains Kubermatic. It's not very nice, but take into account that normally the seed name, when you have a enterprise edition installation, should correspond to a region, so you can have a more meaningful name like Europe.Kubermatic or and so on and so forth. So I create another alias in Paris. So alias, okay. I choose the wrong option. Now it's better. Create record. I will explain you better why we need a wildcard entry later when we will create a user cluster, but let's check for the moment that the configuration has been applied. So again, dig to verify that we get a good value for we are able to resolve basically those IPs. It's a wildcard, so we can put whatever. And yes, the configuration looks good. So this concludes the installation of Kubermatic. Now we can try to access the UI. Up. And here we are. This is the Kubermatic dashboard. Probably I have still, yeah, because I created a platform before, so I have still something in the cache. Let me create a private window to avoid this kind of problems. Okay, this is the UI, so I can sign in using the static password that have been set in the values file. The password is password. And here we are. So first of all, I have to create a project that can be used to logically group some user clusters. I save it. And it is created now. So now we can try to create a user cluster. It is basically the final Kubernetes cluster that will be used to deploy your workload. Can generate a name, a fancy name, choose the Kubernetes version I want. Here I can choose the provider where I want to deploy the worker names. In this case, I only configure it to use AWS, but we support many cloud providers, and you can check the full list in our documentation. Here is the data center. Also here I just configured one, but we could have different regions. So let me just copy my credentials. Here, one option is you can configure another custom resource that is called preset, where we can predefine the credentials. When you create this, you can choose in the drop-down menu, and it's more practical, but here I didn't have the time to do it. So let me create this manually. Here I choose the node settings that are basically the number of worker nodes I want to create, their size, and other configurations like disk size, the image, AMI, and that's it. I can choose also the operating system that will be used by the worker nodes. Here is are the operating systems we support. And finally, this is the latest page where I can check that everything is good and confirm the creation. So now the process of creating the user cluster has been triggered. We can monitor here what is going, or we can also use kubectl. So for each user cluster, there will be a new namespace created in the seed cluster hosting the control plane. So we can check here the progress. Okay, as you see, everything seems to be already up and running. There are some transient issues because there are some dependencies between those components, but it's nothing, it's perfectly normal. As you see, everything is almost up and running. We can wait for the transient issue to be resolved and come back, not here, but to the UI. So let's see, everything looks good, as you can see. Let's see now. The initial node deployment has been created. This triggered the creation of the workers that at the moment is in progress. I just created one worker and it's not ready yet, but the control plane, it's already perfectly working. I can download from here the kubeconfig in order to access this user cluster. Let me do it. And I will, as you can see here, everything is running at the moment. So this is my newly created Kubernetes cluster. Of course, there is nothing deployed on it because it's a new one, but we can see node is not ready yet. You can see that the components are here. We have the CNI initializing. So the first node is almost ready. Everything seems to be working. Yes, in fact, now it's ready. And now we have a Kubernetes cluster ready to be used. So this concludes the demo. Sorry, I was a bit long because of the issue I met during the installation. But now we have time for questions.
Yes, thank you very much, both like you for speaking and the others for listening. We already have a couple of questions, but let me jump to the first one. So an easy one, was this installed on Windows or Linux? Probably you could see that in between.
You mean the workers? If you mean what I used for the installation locally, I used my Mac laptop. But
yes, I meant your local local computer, what you have on it. I saw on the screen it was a Mac.
Yes.
I have Windows, so I don't know.
Yeah, it's perfectly fine because at the end, everything will be, I mean, you just need to have a kubectl that is available and Helm client that are available for all the platforms.
Yeah, but I cannot use command line of Windows. I need to use PuTTY or something.
Actually, with Windows 10, there is a Linux subsystem. You can install Linux distributions like Ubuntu or whatever. But yes, you can also use a Linux emulator or whatever. I mean, it's more handy for you. Then if you really want, you can use the PowerShell or whatever. But I'm more used to Bash, but you can do the same things. Of course, you couldn't use the shell script I used to generate the configuration files for the demo. But if you use a Linux emulator, or if you have a Bash with the Linux subsystem, it's perfectly fine on a Windows laptop.
Okay, thank you.
Welcome.
The next question is does it work on-prem as well, and what are the challenges there?
Yes, I mean, I don't know, Youssef, if you want to take it, but I will just say a few things. Of course, it also works on premise. We support OpenStack and VMware vSphere. But yeah, the thing is that as I showed you, we need load balancer support. So if you want to install Kubernetes on bare metal, you need something that provides service support for services of type load balancers. So something like Metal LB. It's of course it's a bit more complicated than using a cloud provider like AWS, and that's why the demo was based on AWS. But we have customers that are using their own infrastructure, and it's perfectly fine to use it.
Yeah, and just to add what Iacopo said, yeah, as it is on-prem, obviously you're managing your data center, so it's a little bit harder because we have customers that are using Metal LB. It works perfectly fine. I mean, you just need the load balancer to be provisioned. I mean, and that's it. And I think you are pending a question with VirtualBox too. No, it doesn't work with VirtualBox, and maybe Iacopo can confirm. But yeah, you need a proper VMware enterprise, like with vSphere and vCenter and all that kind of stuff to connect to it, and basically then you can obviously be able to provision the worker nodes.
Yeah.
I have one more question. What is the difference between Kubermatic Kubernetes Platform and the Cluster API?
Well, the Kubermatic Kubernetes Platform is implementing the Cluster API. It's implementing a quite old version of the Cluster API that is V1 Alpha 1, because there are a lot of it's moving a lot, and of course we cannot follow all the changes, but as soon as there will be a stable API, we will probably migrate to it. And note that there are other providers that made the same choice. For instance, also OpenShift, I think it's on the same Cluster API version, that we're using basically.
All right. I'm checking if there are any more questions.
If there are no questions, so maybe I can take just 10 seconds to complement the answer I gave before regarding the possibility of using in-premise infrastructure. Actually, with Kubermatic, you can also have a so-called hybrid cloud. So you could basically, I don't know, having the seed cluster and the part of the Kubernetes infrastructure on premise, and then having the worker nodes on cloud, on public clouds, and you can have on the same platform, you can have, for instance, user clusters on premise and on different cloud providers. So this is, I think, is quite a good thing for flexibility. That's it.
All right. So any more questions? Does not seem so. All right. In case more questions come up, we do have a forum where you can ask questions. Of course, you can always check us out on GitHub and then create issues for the project. And we also do have a Slack channel. I will post both, like the forum and the Slack channel now. So yeah, there is like there are many different ways to exchange with us. I thank you all very much for joining. As I said, I will upload a recording in the coming days. So if you had to drop out early, then you're not there anymore and then listen that. But then you can, but if you, for example, missed the beginning, we will upload this in the upcoming days. And with this, I want to come to an end. I wish you all a nice evening, day, depending where you are. And yeah, hope you check out our project on GitHub, start to play around with it, install it, and maybe leave us a star in case you like it. And that's it for today. Thank you very much. Bye.
Thank
See
you.
you guys. Bye.
Thanks. Bye.